Hi everybody. Today we're going to continue our weather unit and we're going to be discussing different types of air pressure. So often when you watch the Weather Channel, if you notice, the meteorologist will either be standing in front of a map of the United States or possibly just the region where you live. And on those maps you'll see there would be a capital H or a capital L depending on the type of air pressure in that area. When you see the capital H, it's always going to be in blue, and L is always going to be in red. Okay, so some things to recall. We discussed air pressure is the weight of the atmosphere on a certain area. So really what that means is it's just the weight of the air that's pushing down on Earth at a specific time. And when we measure that, we call it barometric air pressure or barometric pressure. Now, when we measure the air pressure for a specific location, we use this little tool up in the top right corner. And if you recall, this is called a barometer, right? Barometric pressure, so they use barometer. So, barometer. Okay. And basically the way that this works is if there's a lot of air pressure in that area, there's a little spring inside. And when that spring gets compressed, the little needle will change its direction of where it's pointing. So if it's pointing in this way, or it might be pointing in that direction, depending on the air pressure for that area. The units that we use to measure air pressure are going to be millibars, which in short is MB. And we also use inches of mercury, and the abbreviation for that is inches of Hg, or mercury. Okay, when we show different types of pressure on a weather map, we use the small lines called isobars. Again, bars because it's barometric pressure or barometer. And what those isobars do is they connect points of equal air pressure. Right, when you have an area with a blue H, that shows us that that area is a high pressure system, and then the red L indicates a low pressure system. So take a second to figure out, is this a high pressure system or a low pressure system? One thing to note are the lines and the numbers that go with the lines. So the barometric pressure, you notice, is getting lower and lower and lower. So due to that, this would be a low pressure center. So you would use the big red L for that. In this example, if you notice, you have 1,012 millibars, 1,016 millibars, 1,020, and 1,024. As you get closer to the center, they are increasing, so that would indicate a high pressure center. So the reason that we have differences in air pressure are due to the way that the ground or that area heats up. So we discussed previously that different locations will heat up or cool down at different rates. So that's one of the main reasons for differences in air pressure. And another reason would be how much moisture is in that area. We're going to talk about both of those in more detail right now. So temperature versus air pressure. We all know that warm air is less dense than cold air, which causes warm air to rise. And because of that, it has a lower air pressure than cold air. Cold air, on the other hand, is more dense, therefore it's going to have a higher pressure. All right, so high pressure down here, cold, more dense, where low pressure is warmer and less dense. Moisture is also a factor. Moist air, is less dense than dry air, and the result is that moist air has a lower pressure. Dry air is more dense, therefore it has a higher pressure. We're going to talk about that right now. So dry air is going to be more dense because in dry air you only have nitrogen and oxygen, and they have an atomic mass of nitrogen is 28, oxygen is 32, where moist air has nitrogen and oxygen, but it also has water vapor. And if you notice, water vapor has a lower atomic mass, therefore it's going to be lighter. If you look in this photo here, we've seen this a few times before. Moist air has less molecules, right? So you can see there's less warm air molecules here, and they're filled in with the water vapor. And because water vapor is has a lesser mass, it's not going to weigh as much as all of these over here, which have a much higher atomic mass. So the more cold air molecules, the heavier it's going to be. So when you put those two pieces together, we have a cheesy little saying for high pressure, and I want you to write this down. So high pressure systems are generally cool and dry, so that means like nice weather. So we say happy high equals a cool and dry day. So we could say nice weather. Put nice out. On the other hand, when you have low pressure, usually it's going to get warm and humid, and that leads to stormy weather. So the saying for that is lousy low equals warmer, comma, rain or snow. All right, so that means it's going to be nasty weather. Okay. All right, so if you look in your reference table, we've discussed this here. So you have your air pressure, the units, you have millibars. On this side, you have inches of mercury. And I believe we wrote in our reference tables, we drew a little sun on the high pressure side. So any pressure that's above 1 atmosphere is considered to be high pressure. So if you want to write this in your reference table, you can write happy high, cool and dry. And if it's lower than 1 atmosphere, that's going to be a stormy day, kind of not so nice out. So we say lousy low, warmer, rain, or snow. Okay, so we're able to use a barometer to determine what's happening to the weather conditions outside. If you recall, on a station model, we had a round circle here, and just in this little spot right there, we had either a plus or a minus, and that indicated whether or not the barometric pressure was going to be rising or falling. Okay, so let me erase this. If we have rising barometric pressure, that means you would have a plus, and then let's say the number was 2 millibars, and then you draw your little slope rising. That means it's going to get better outside and cooler and drier. So if you recall, happy high, cool and dry. On the other hand, if you have falling barometric pressure, here's your station model, you have a minus sign and then a slope decreasing. You would expect to have lousy weather, right? Lousy low, warmer, rain or snow. So if you ever thought about the wind, right, moving air, wind is created by differences in air pressure. Right, so when certain areas heat up or cool down, you're going to get differences in air pressure. Some areas will be high, other areas will be low, and that creates movement in the air from side to side, and that's what you feel, that's what we call wind. Now, when there is a really large difference between two areas' air pressure, you're going to have very high winds. If the difference between the air pressure is not so high, then the wind will be very low or light. Now, when we look at air pressure on a map, we can look at the isobars, right? Remember we said isobars for barometric pressure. If we look at the spacing between those isobars, it can tell us if the winds will be moving quickly or if they will be moving slowly. So I know this is a lot, but if the isobars are close together, then you're going to have a big change in the air pressure. There's going to be a big or large pressure gradient, and that leads to high winds. I'll show you what that looks like in a second. If the isobars are really far apart, then that means that there's a small pressure gradient, so there's not a lot of difference between the two areas, and that's going to lead to really low or slow winds, or maybe not even any wind at all. So if you take a second to look at this map with our isobars, where would you find the fastest winds? Right, so this area over in here, if you notice, the lines are very close together. So closer together. And that's going to lead to fast winds. On this side over here, the lines are very spaced out, so far apart. And that's going to lead to slow winds. You may recall this looks very similar to when we discussed elevation maps or isotherm maps for temperature. Same idea. Now, when winds blow from one place to another, they always go from an area of higher pressure to lower pressure. You can kind of compare this to a balloon. Right, so if you imagine this was a balloon and you were to fill it with air molecules, right, so you're forcing them into the balloon, the pressure is going to become much higher, and that's what causes the balloon to get bigger and bigger and bigger. Right, but over time, those molecules, if they build up even more, they're going to want to escape. Right, so they always blow from areas of high pressure to low pressure. So if you were to release that balloon, all those air molecules would blow outwards in that direction. So always going to be from high to a low pressure. Now, due to Earth's rotation, we have something called a Coriolis force or Coriolis effect. And what this does is, as the Earth is rotating, it causes freely moving objects, such as air molecules, to turn to the right in the northern hemisphere, and in the opposite hemisphere, so the southern hemisphere, they turn to the left. So if you think about it this way, let's say that Butters is trying to throw a rocket or shoot a rocket towards Kenny over here. If he throws it in a straight line, because the rocket's in the air, it's going to appear to curve to the right in the northern hemisphere. And the reason for that is because while that rocket is in the air, the Earth is rotating below it. And by the time that rocket hits the ground, the Earth will have rotated a certain amount, and that causes that rocket to appear to curve to the right by the time it lands. So this is an aerial view from the top. So if you put it all together, in the northern hemisphere, high pressure is always going to rotate clockwise and outwards, or away from the center. If you think about a clock, that was a clock, right? Clockwise would be the normal direction that a clock moves. On the other hand, you have low pressure, that rotates counterclockwise and towards the center. And again, if this was a clock, counterclockwise would be the opposite way that a clock rotates. So what that looks like is this. Let me change my color. Okay. So clockwise and away from the center for your high pressure. Remember, you're going to have to be able to draw this on your own. So high pressure is going to go outwards and turns to the right in the northern hemisphere, so clockwise. It's going to go out and then turn to the right in the northern hemisphere. It's going to go out, turn to the right. It's going to go out and turn to the right. So it's going clockwise. All right, we drew a clock. So it's rotating in that direction. Now for low pressure, it's going to go counterclockwise. So if this was our clock, it's going to go in the opposite direction. So I'll start at the bottom here, and it's going to go in towards the center and counterclockwise. Okay, so counterclockwise and in towards the center for low pressure. So I'd like you to take a minute or two to look back at the notes, and I want you to compare the high and low pressure for the weather conditions, the wind pattern, and vertical air currents, meaning is the air going to be rising or sinking? Okay, so for high pressure, the weather conditions, if you recall, we said happy high, and then the saying goes cool and dry. So that means it's going to be a pleasant day. For the wind pattern, high pressure goes clockwise and blows outwards. And the vertical air currents, since it's got a high pressure, that means there's a lot of molecules, so they become very heavy. So if it's, we'll say, high pressure, I put equals heavy, that means the air is going to sink. So we'll put sinking air. Okay, let's move on to low pressure. So for low pressure, if you remember that cheesy little saying, lousy lows, warmer, rain or snow. So that means it's going to be lousy out or lousy weather. Okay. For the wind pattern, for low pressure blows counter clockwise and inwards towards the middle. Okay. And for the vertical air currents, because it is low pressure, that means there's not a lot of molecules. So low pressure equals light weight. And you could also think of warm air, right? And warm air likes to rise. So we'll say rising air. Okay, so this is really important. These are the takeaways that you need to understand for these notes here.